So let us start today class. I am Dr. Juhi Jaswal, your course instructor for this course. The course name is Mathematics 2, in which we are going to learn some linear algebra concepts as well as linear programming concepts. So before this whole course will be divided in two parts. Before midsem we will cover linear algebra. After midsem we will cover linear programming parts. So as you people said that you are not aware of this group theory, although I am starting from basic, if you have any doubt in between, you may ask by enable your mic. Please do not unmute yourself if you don't have any query, otherwise the class will be disturbed. Okay. Now what is vector space, and we have to read vector space over real and complex fields only. So before that we need to know what is field. Basically, a field is a set F which containing at least two elements on which two operations O plus and C dot, this sign is called as O plus and this sign is called as C dot, which is known as addition and multiplication, are defined so that each pair of element xy in F, there exists a unique element which relates x o plus y and x dot y, and again these resultants will go to this F only. Not only this, but we have some other properties also which must be satisfied if the given set is a field with respect to these operations. What are that? The first one is that commutativity of addition. This means what? X o plus y should be equal to y o plus x. Means either we add x in y or we add y in x. Both must be same. The second property says that associativity with respect to addition. This says what? Yes, anybody have any query?
मैम
No,
एक बार
ma'am.
डेफिनेशन दोबारा से बता दीजिए.
Okay, I have not finished it. Let me first state once, after that you may ask. What I am saying, a set is basically a field which contains at least two elements and with two operations. One is known as addition, second one is known as multiplication. How these operations are defined, that whenever we take two elements x, y in this field F, then x plus y and x dot y should be defined and it belongs to that set F only. This is known as closure with respect to given operations, closure property. Closure property Y means the set is closed with respect to this, means whenever we are taking two different elements, their operational result means x plus y and x dot y, whenever x and y belonging to that set, should also be in F. And whenever we take three elements x, y, z, then this set of 9 properties should be hold. If this set of 9 properties will hold, then we will say that F is a field with respect to these two operations, F plus dot, O plus and C dot. Now what are these 9 operations? First one is says that commutativity of addition. Means either we add x in y or we add y in x, both result are equal. The second says that associativity of addition, means either we add x plus y and then we add the resultant in z, or we first add y, or we add y plus z and then add resultant in x. Both final results will be same. The third property said that there exists a unique additive identity. Additive identity is what? This says that there exists an element of 0 in F such that whenever we add this 0 in X, this is equal to X. Later we will see how we will calculate all these things and how it looks like. The next property says that existence of unique additive inverse. Means what? For any given x in F, there exists an element of type minus x such that x plus minus of x is equal to 0, means additive identity. The next one is says what? With respect to this second operation, C dot operation, this is commutative, means commutativity of multiplication, means either we multiply x in y or we multiply y in x, both result will be again same. The next property 6.1 is says that associativity in multiplication, means either we multiply x into y and then whatever result we are obtaining in that we multiply z, that will be equal to if we first multiply y into z and then we multiply the resultant with x, both quantities will be same. The seventh property says what? Distributivity over of multiplication over addition. It says what? If we add two elements x plus y and then in the resultant we are multiplying z, this will be equal to x multiplied by z, y multiplied by z and their addition. Means either we multiply z in each component and then add z. This will be equal to first we add x and y and then multiply the resultant with z. The same thing holds with right also, that if we have x dot y o plus z, this will be equal to x into y plus y into z. Sorry, x into z. This is known as distributivity property. Why? Because this multiplication is being distributed over addition. Like see here, whenever we have y plus z, it will be distributed with y as well as z. The same thing is happening here. The next one is says what? There exists a unique multiplicative identity. Multiplicative identity is what? It says that there exists an element 1 in f such that 1 is not equal to 0 and x into 1 is equal to x. And the last one is says that existence of multiplicative inverse, which says that for any non-zero x, we have an element x inverse in f which gives us x into x inverse is equal to 1, multiplicative identity. Whenever we are able to define we are able to define two operations on any given set which satisfy all these 9 criteria, we will call that f is a field with respect to these two operations. Anyone have any doubt?
Ma'am, please explain last point.
Last point says that whenever we have some non-zero x, like in the additive inverse, existence of additive inverse, what we have seen, for each x, there exists an element minus x, whose sum with this x gives additive identity. The same thing will happen with multiplicative operation also, but the condition will be what? For x not equal to 0. Whenever x is some non-zero element, there must exist some element x inverse whose multiplication with respect to this x gives 1, multiplicative identity. Like let us see one example. Let us take real number set. How we denote real number set? By this R. Are you all of aware with this? This denotes set of real numbers. Please mute your mic. Then what it says that the first thing it's with respect to usual addition and usual multiplication. Plus operation is our simple plus, usual plus. And dot operation is our usual multiplication. So if I am taking the real number set and I define two operation, let us see first condition is satisfied or not. containing at least two elements. R is non-empty. It have more than two elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is non-empty and contains at least two elements. Condition satisfied. Now let us see first one. No, before that we will see whether this condition holds or not. So whenever we are multiplying two numbers or adding two numbers, let x and y belonging to R, then x plus y will also belong to R. Yes or no? Addition of two real number will be a real number. Please answer.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
What about x into y? Product of two
Yes,
real
ma'am.
number
Yes,
will
ma'am.
Ma'am,
also
real
be in a
number. It
right.
will also give a real
Belong to
number.
real number.
Yes. So first thing is satisfied that it has at least two elements and the product and sum of any two numbers in R is again going in R. Please mute your mic. Now let us see with the second one, commutativity property. If R is a real number, commutativity of addition.
Ma'am, I also have a doubt.
Yes.
Ma'am, why it is termed as field here? Because these are the simple things which we are learning from class since fourth. Like,
Means field means what? Why this nomenclature is there?
no, I mean, why it is called as field?
Because we have actually in background we have more things like ring, integral domain, field. All those things are defined which have some specific kind of properties.
Okay, ma'am.
Okay. So commutativity of addition, let us see. If x plus y means either we take x, y in z, these two condition hold. Now let us take that x, y, z belongs to real number set. Then x plus y will be what? Will x plus y is equal to y plus x for every x and y? Whenever it is real number? It is
Yes,
true, no?
ma'am.
Second one
Yes,
is
ma'am.
associativity. Whenever we have associativity with respect to addition.
Yes, ma'am.
If I add x plus y and in that plus z, will this be equal to x plus y plus z in respect to addition, usual addition
Yes, ma'am. Equal.
for every x, y, z in R? The next says
Yes,
that,
ma'am.
yes, the next one says that the existence of 0. 0 is belonging to our real number. And whenever we add x plus 0, what will be our resultant?
X.
Real number. X.
So existence of additive inverse is fixed. What if I take? Please mute your mic. What if I take x in some real number? Then can I get any number y such that x plus y is equal to 0? Additive identity?
Minus
Please.
x.
Ma'am, in place of y, we will take minus x. Then the result will be 0.
Right. So whenever we will replace this, so this says what? There exists y is equal to minus of x such that x plus of minus x is equal to 0. Existence of additive inverse is satisfied.
Yes, ma'am.
Now let us see commutativity with respect to multiplication. Whenever x and y are real number, will x into y is equal to y into x? 2
Yes,
into 3
ma'am.
is equal to 3 into 2. Hold. Next one is associativity. Whether x into y into z is equal to x into y into z. Is this true for real number set?
Yes, ma'am, it's true.
Yes, ma'am. True.
Seventh property is what? Seventh one is what? Distributivity. What if x plus y into z? This will be what?
XZ plus YZ.
Xz plus yz. So first distributive hold. What about x into y plus z? What will be
XY
this?
plus
Ma'am,
XZ.
XY
XY
plus
plus
XZ.
XZ.
Xy
XY
plus
plus
xz. Distributive property hold. It is left as well as right distributive. The next one is existence of multiplicative identity. We all know that 1 is a real number which multiplied by any other real number will always give the same number. That means x into 1 is equal to x.
Yes, ma'am.
Yes or no?
Yes,
Ninth
ma'am.
one says what? Whenever we have x in R, thus there exists 1 by x in R such that x into 1 by x is equal to 1, because
Yes,
these are
ma'am.
real number until and unless x is not equal to 0. Because whenever it will be 0, 1 upon 0 will not be defined. So whenever a non-zero x we can take in R, we will always get a 1 by x in R which gives x into 1 by x is equal to 1. Can I say this x inverse name as 1 by x? This will be
Yes, ma'am.
multiplicative inverse of this. So all the set of 9 conditions as well as closure property holds for this set are. Now after all this discussion, can I say that R with respect to addition as well as usual multiplication is a field? Can I say? Please answer. After verifying all these
Yes,
properties,
ma'am.
okay. So, okay. So this, whenever we are dealing with only R, this is known as real field. Real field means
Ma'am,
element. Yes.
ma'am, can you explain the seventh point?
Okay.
Ma'am, both result is not same, I think. Ma'am, point 7.
7 point says what? First one says that x plus y into z multiplication is distributive over addition. So whenever we add x and y and then in the resultant we multiply z, that will be same as if we multiply z in each component and then add the result. So x plus y into z is equal to x for real number when we are dealing. Is this condition holds? Whenever we x plus y into z is equal to x into z plus y into z.
Yes, ma'am.
And the next one in seventh part says that addition is also left distributive over addition. That either we first y into z and then multiply the resultant with x, that will be equal to x into y, means again we multiply x in each component and then add the results. So
Yes,
for the
ma'am.
case of real number, this is holds. Actually, this one is known
Yes,
as,
ma'am.
first part in 7th one known as right distributive, and this one is known as left distributive. Multiplication is distributive from right as well as left.
मैम यहाँ पे both equal होना चाहिए था क्या? I mean right distributive and left. और
नहीं,
ये दोनों अलग अलग हैं.
ये दोनों अलग अलग है ना, क्योंकि हम x
Yes,
प्लस
ma'am.
वाई में z का मल्टीप्लाई कर रहे हैं और y प्लस z में x का मल्टीप्लाई कर रहे हैं, ये दोनों तो डिफरेंट नंबर्स आएंगे ना.
Yes, ma'am. हाँ, yes, ma'am. Okay, ma'am. Thank you, ma'am.
Okay. So with these usual operations, r plus dot is a field, and we call this field as a real field. Can you verify all these things with set of complex number with usual addition and usual multiplication?
No, no.
Why? Why you can't verify?
नहीं, not.
I'm sorry, someone is trying to say something. See, why you can't verify? Whenever we will take two complex numbers,
Yes, ma'am, we can.
so it is your homework. Please verify whether this is a field or not. If you found
Yes,
this is a field, then this, please mute your mic. Then this field will be called complex field. Although EG, please mute your mic.
भाई माइक म्यूट करो।
आशीष कुमार माइक बंद कर ले भाई।
आशीष माइक बंद कर लो।
Everyone, please mute yourself if you have any query. Otherwise, the class is going disturbed. I have enabled your mic so that we can interact. Because whenever I am sharing the screen, I am not able to see your messages. So it is your homework for today. Verify whether this C with respect to usual addition and usual multiplication is a field or not. For more specification, I can define C is what? Set of numbers A plus IB, where A and B are real numbers. How addition and multiplication is defined? If we take A1 plus IB1 and A2 plus IB2 in set R.
Y is
Yes.
integer.
I is iota. This is a symbol.
Okay.
imaginary number. I mean,
Yes.
I stands for.
Then your A1 plus IB1 plus A2 plus IB2 is defined by A1 plus A2 plus I B1 plus B2. And product is defined how? A1 plus I B1 into A2 plus I B2 is equal to A1 A2 minus B1 B2 plus I A1 B2 plus A2 B1. This is how your addition and multiplication are defined on complex set. And this is your set of complex numbers. Please verify whether this is a field or not. Today evening also there is class, na?
Yes, ma'am.
Yes, ma'am.
Yes,
So in
ma'am.
the next class, I will ask you whether this is a field or not. For the now, I assume that that is a field. And now we will move forward. Okay, other examples can be rational number set, integer number set. Okay, integer number set is not a field. Why? Anybody can tell? Whether for any x in z, we will be able to find x inverse, which will give x into x is equal to 1. बताइए?
No, ma'am.
No. That's why this is not a field, because one property is not holding there. This one I have verified. Please do your homework and with verify whether these are statements are true or not with respect to. I have defined only usual and multiplication as well as usual addition, which we are utilizing in our regular life. Now, what is a vector space? For vector space, what we need 3-4 things. Please mute your mic. For vector space, we need 4 things. First one, what we need a field. That's why I have defined first field. Second, we need a set V, capital V, which will contain some element and 2 operations defined on that. First one is known as binary operation or vector addition, which will relates the elements of V to V. Means this will be defined from V cross V to V. And second one is a binary function which relates from V cross F to V. Means for vector space, what things we need? First, we need a non-empty set V. Second thing, we need a field. Third, we need a binary operation. Let us call it O plus or simple plus, which will be defined from V cross V to V. Means this will relate elements of V again with V. And second one, operation, let us call it C dot or simple dot. This will be defined from F cross V to V. How they will be defined? Like whenever we have x, y in V, then x plus y also belongs to V. And how this second multiplication, second operation defined, binary function defined for alpha in V, sorry, alpha in F. Alpha will confuse, so I will write A. For any scalar are A in F and V in X, let us take X. What we have taken there, let me just see. Q, V and A, okay. For notation consistency, let me write it again. Whenever V1, V2 belongs to V, then V1 plus V2 should also belongs to V. And for any A in F, V in V, alpha into V, sorry, A into V will also belongs to V. The first operation is relates two numbers. That's why it is called binary operation. Second one is called binary function. Why? Because it is defined from f cross v to v. The elements of this f is known as scalars and the elements of v are called vectors. And that's why the name is vector space. Whenever these four conditions hold, in addition to that, if these remaining 8 conditions also hold, then we call that this V is a vector space over the field F with respect to these two operations, whatever will be defined. Here we have defined plus and dot, so with respect to plus and dot. And how we will write that? I am just coming, what are the 8 properties? How we will write a vector space V over F plus dot. Whenever the operations are clear from the context, we will usually write V over F. Now let us see what are the remaining 8 properties which should be satisfied. First one is again associativity with respect to vector addition. Means if we have 3 vectors u, v and w, then either we add u in the resultant of v plus w or we add w in the resultant of u plus v, both must be same. The second one says that commutativity of vector addition means u plus v should be same as v plus u. The next one says that identity element with respect to vector addition. This means what? There exists an element 0 in V, which is called 0 vector, such that V plus 0 is equal to V for every V in V. And the next one is what? Existence of inverse of vector elements, which says that for every V in V, there exists an element minus V in V called as additive inverse of V, such that V plus into minus V is equal to 0 vector identity. This is 0 vector. Here 0 is representing vector, means it will be member of this V. And the next one says that what? Compatibility of scalar multiplication with respect to field multiplication, which says what? A into BV is equal to AB into V. Means either we multiply first B in V and then multiply A, or we first multiply A and V and then multiply V. The resultant will be same. The sixth property says what? 1 into V is equal to V, where 1 denotes the multiplicative identity in F, means field. फील्ड की एडिटिव आइडेंटिटी तो हमें पहले से पता होगी ना जब फील्ड दिया होगा तो. For that number 1 into V will should always give V. And now the distributivity of scalar multiplication with respect to vector addition says what? A into U plus V is equal to AU plus AB, and A plus B into V is equal to AB plus BV. Means scalar multiplication is distributive over addition as well as scalar multiplication is distributive with respect to field addition. For vector addition also it should be distributive, and for field addition also it should be distributive. Whenever all these 8 conditions will hold, we will say that the given V with over this F forms a field with respect to these two operations, plus and dot. And if we are restricted to take F either R or C, means real number or complex number, then the vector space are known as vector space over real field or complex field. If it is R, it will be called as vector space over real. If it is C, we will call this vector space over complex numbers. Now, anyone have any doubt in these 8 properties? Otherwise, we will go with examples.
You may continue, ma'am.
Okay.
Continue, ma'am.
Okay. So let us first one verify. Let V be a set of n cross 1 column entries of column matrices of real numbers. and let the field of scalars be R and define the vector addition and scalar multiplication by this one, that x1 x2 xn plus y1 y2 yn is equal to x1 plus y1 x2 plus y2 xn plus yn, and c into x1 x2 xn is equal to cx1 cx2 cxn. Let us verify it is a vector space or not. V is equal to collection of x1 x2 xn pair. These xi belongs to real number set for every I lying between 1 to n. Fine. Can I denote this set as also as Rn? If I denote it this Rn, anybody have any issue? Okay. For the right now, we will not take it Rn. And field is what? F we have taken set of real numbers.
Ma'am,
Operation is
Rn is just a notation or it is raised to the power R.
R to the power n means R cross R cross R up to n times. Tuple. Like whenever we write R2, it denotes R cross R. What are the elements of this R2? Of tuples of the form x comma y. Similarly, if we will take some element in Rn, then it will be tuple of x1 comma x2 comma xn.
Okay, ma'am, got it.
Okay. So now let us come with this one. Operation is defined how? For x1, x2, xn. Let me write more clearly. Vector addition. Vector addition is defined how? x1, x2, xn plus y1, y2, yn. Matrix addition, all of you aware with matrix addition and multiplication, na?
Yes, ma'am.
Yes.
Yes, ma'am. Yes, ma'am.
Element wise, the same thing happens here because this is also n cross 1 matrix. x1 plus y1, x2 plus y2. Some will be
Ma'am,
defined element wise, yes?
ma'am, during vector addition, we are just dealing with magnitude of vector or we are taking as well as direction component in it or only magnitude.
Okay, that is a very good question. But these vectors are not your that vectors which include magnitude and direction. Here, the elements of V are simply called vectors because this space is defined as a vector space. However, if you want to compare with that, whenever we will denote some number in R2, means complex or this Cartesian plane, right? What will be the number 1, 2? 1 will be somewhere, 2 will be somewhere, right here, 1 and 2.
Yes, yes, ma'am.
So in itself, it consists its direction as well as magnitude.
Okay, ma'am.
But here we will not be more focused about direction or magnitude. Here, whatever will be the elements of this V, we will call those element a vector. And elements of F means uh, whatever will be the member of this set F field, those will be called scalars. Clear?
Okay, ma'am. Thank you, ma'am.
Okay. How scalar multiplication is defined? If C is any scalar and x1, x2, xn is a member of our V vector, then This is scalar multiplication. How we define scalar multiplication of matrix? Scalar we go and multiply in each entry, right?
Yes, ma'am.
So this is the same as if you consider your usual addition and usual scalar multiplication of matrices. So first two conditions hold. We have given member of this. We have two given set V and F, as well as the operations are defined. Now let us verify for the remaining set, this properties. U plus V plus W is equal to V plus U plus W or not. For the nomenclature, let us take x1 is equal to, or xyz, I may take, it will be easy and differentiable. x1, x2, xn, y is equal to y1, y2, yn, and z is equal to z1, z2, zn. Then first one we want to see x plus y plus z will be what? This will be x1, x2, xn. Can I write y plus z directly by this operation?
Yes, ma'am.
Yes, ma'am.
Plus y1 plus z1, y2 plus z2 up to yn plus zn. This will be equal to x1 plus y1 plus z1. Again we will add, these are again two vectors, no?
Yes, ma'am.
x2 plus y2 plus z2, xn plus yn plus zn. Now since all of these are real numbers, can we interchange the bracket? Means x1 plus y1 plus z1 is equal to x1 plus y1 plus z1. Can I write this one as this one? Let me
Yes, ma'am.
Yes, ma'am.
associativity of real
Yes,
number
ma'am.
we can utilize.
Yes,
This will
ma'am.
be equal to x1 plus y1 plus z1, x2 plus y2 plus z2, xn plus yn plus zn. Now this quantity, can I take z1, z2, zn outside? Will this be equal to x1 plus y1, x2 plus y2, xn plus zn? Plus,
Ma'am,
sorry,
xn
this is
plus yn.
yn, sorry, z1, z2 up to zn.
Yes, ma'am.
And can I write this as x plus y in plus z? This is true.
Yes, ma'am.
So associativity with respect to vector addition holds. Now we will go with the second one. Second one is says what? Commutativity with respect to vector addition. So this holds. Now for the second one, x plus y is equal to what? This will be equal to x1 plus y1, x2 plus y2, xn plus yn. This is true.
Yes, ma'am.
This is Now, by utilizing the property of commutativity of real numbers, can I write this as y1 plus x1, y2 plus x2, yn plus xn?
Yes.
If I can write this one as this, the second one is what? This is simply y plus x, right?
Yes, ma'am.
So commutativity with respect to vector addition also holds. The next property is what? Identity element of vector addition. So in the set of real numbers are this V is defined how? X1, X2, Xn, where each xi belonging to R, then 0 is also belonging to R. If 0
Yes,
is
ma'am.
belonging to R, whether the all elements with 0 means 0, 0, 0 n times n cross 1 0, will this be a member of V? बताइए. I am saying if x is real number, whether 0, 0, 0, which is a n cross 1 matrix, whether this belonging to V, क्योंकि है तो real number ही.
Yes, ma'am.
Yes, ma'am.
So if this belonging to V, and let us denote for the sake it by 0 bar to differentiate with, what will be x plus 0 bar? This will be equal to x1
X.
plus 0.
X.
Yeah, it will come x. Let me just write one or two more steps. This will be the same. Now, since these are real numbers, this will be equal to x1, x2, xn, and this will be our capital X. So, existence of additive inverse is fulfilled. Sorry, existence of
Yes, ma'am.
vector identity,
Hmm.
a vector 0. The fourth property is in that what we have to show, for any given vector v, there exists an element minus v in v, which gives v plus minus v is equal to 0. If we are taking x a member of this v, then which is defined by how? X1, x2, xn. X is equal to x1, x2, xn. x1, x2, xn are all real number. So minus of x1, x2, xn will also be real numbers.
Yes, ma'am.
Yes, ma'am.
So can I say that there exists an element minus x1 minus x2 minus xn in v, क्योंकि ये भी real numbers ही हैं. If for right now I denote it as y, there exists a y which is defined by this such that x plus y is equal to x1 minus x1, x2 minus x2, xn minus xn. This is equal to 0, 0, 0. So this y is what? Can I denote this y by minus of x? Because this is just a notation, minus v. Here it is
Yes,
not
ma'am.
negative of that. So existence of vector, what is it? Vector addition, inverse of vector addition. Existence of vector, inverse of vector addition is satisfied. Fourth criteria is also satisfied.
Yes, ma'am.
Now fifth condition is what? A into B into V is equal to AB into V. For fifth condition, let A and B be scalars. Scalars means member of field. Here we have already taken F as R, so we'll write AB in R. And X is a member of V, then A into B into X will be what? A into Bx is defined how? बताइए, यहाँ पे Cx डिफाइन CV डिफाइन किया था ना ये. Each component will be multiplied by the scalar. So
Yes,
with
ma'am.
this definition, what will be Bx?
Ma'am, Bx1, Bx2 up to Bxn.
Up to Bxn. Now again, when this A scalar will be multiplied, what will be the resultant?
Ma'am,
A
ABx1, ABx2 up to ABxn.
right. And by the property of real number, ABx1, can I write this as AB into x1? क्योंकि real number है. Real number में
Yes, ma'am.
multiplication associativity follow होती है.
Yes, ma'am.
AB into x2 up to AB into xn. And this one is what? Nothing but AB into x. Multiplication compatibility hold. Now the sixth property is what? 1 into V is equal to V. 1 belongs to R, a real number, which gives 1 into x is equal to will be what? 1 into x1, 1 into x2 up to 1 into xn. 1 into x1 will be 1, sorry, x1, x1, x2, xn. And this is what? Nothing but x. So this condition also holds 6, 1 into V is equal to V for every
Yes,
V in F, for every V in V. The next one, let us see distributivity. A into U plus V. A belonging to F and XY belonging to V, then A into X plus Y is equal to what? This will be equal to X1 plus Y1, X2 plus Y2, Xn plus Yn. Scalar multiplication will be multiplied in each component. A into X1 plus Y1, A into X2 plus Y2 up to A into Xn plus Yn. Now X1, Y1 are real numbers. A is also a real number. Can I write this one as AX1 plus AY1 by distributivity of real numbers over addition?
yes, ma'am.
क्योंकि
Yes,
real
ma'am.
number filled था. AX2 plus AY2,
Yes, right now.
yeah,
Yes, ma'am.
AXN plus AYN. इसके बाद आप लोग की क्लास है क्या?
No.
No, ma'am. No, no, ma'am.
Okay, I will just take 5 minutes more, not much.
Okay,
Okay,
okay.
ma'am.
Okay,
Okay.
okay.
So
Okay, ma'am.
this one, can I write this one as AX1, AX2, AXN plus AY1, AY2, AYN This is the same thing.
Yes, ma'am.
Yes, ma'am.
And the last matrix which I have written, this is the same as ax plus ay by definition of scalar multiplication. Yes or
Yes,
no?
ma'am. Yes, ma'am.
Yes, ma'am.
So distributivity of scalar multiplication over vector addition is satisfied. Now let us go with the next one. Distributivity of scalar, what is that name? Distributivity of scalar multiplication with respect to vector field addition. If A and B are two members of R and X is any member of V, then A plus B into X is equal to what? A plus B will be a scalar. This will be A plus B into X1, A plus B into X2
A plus
up
B
to,
into x3 dot dot dot
yes,
a plus b into xn.
right, A plus B into Xn. And
Xn.
again, by utilizing the property of real number set, because there's form of field, distributivity of multiplication over addition of field, that property, last one. Can I write this one as ax1 plus bx1,
Yes, ma'am.
ax2 plus bx2 up to axn plus bxn? Again, this vector, can I write this one as ax1, ax2 up to axn plus bx1, bx2, bxn, right?
Yes,
This
ma'am.
step is correct. So what is
Yes,
the
ma'am.
last one? Last one is ax plus
Plus
bx.
BX.
So last property is also satisfied. So what we have seen, if we are taking this v as a real number, which made it,
भाई माइक बंद कर.
if we take this v as a set of real numbers, are n cross 1 column matrices whose entries are coming from real number, and define two operations like this one, then this is a vector space. बताइए, ऑटो प्रॉपर्टी तो सेटिस्फाई हो गई ना?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So for this one, what we can say, this v, this is a vector space v over f with respect to addition as well as multiplication. Now for the second one, please do your exercise. Whenever this v is a set of n cross 1 column matrices of complex numbers, and the field of scalars, let the field of scalars be C, and define the vector addition and scalar multiplication of by this, and verify whether this is a vector space or not.
Okay, ma'am.
Third one we will do in the evening class. We will see
Thank
how
you,
this is
ma'am.
forming a vector space. Thank you, everyone.
Thank you,
Okay,
ma'am.
with
Ma'am, I have a request, ma'am.
Thank you, ma'am.
Yes, please.
thank you.
Ma'am, do you upload the PPTs of this lecture on Moodle and also the handwritten